Parallel lines do not cross. They have the exact same slope. Perpendicular lines cross at a 90-degree angle. Their slopes are opposite signs and reciprocal fractions. So notice I said perpendicular lines cross at a 90-degree angle. So it's not just two lines that cross. They specifically have to make a nice, pretty corner. The types of questions I'm going to ask you about parallel and perpendicular lines are, I'm going to ask you to compare two lines and determine if they're parallel, perpendicular, or neither. They just cross some other random angle. And I am going to give you some equations and ask you to write a parallel line that goes through this point or a perpendicular line that goes through a point. So let's do some examples. Example 1 are y equals 1/2 x minus 5 and x plus 2y equals 8 parallel, perpendicular, or neither. Parallel and perpendicular purely compare slopes. They are defined based on slopes. So all we have to do is compare the slopes of these two equations. The first equation is already written in slope-intercept form, y equals mx plus b. So we can straight up pick the slope out there. It's 1/2. The second equation, we need to rewrite it first before we can figure out what the slope is. So I'm going to subtract my x over to the other side and divide everything by 2. Everything by 2. That includes the y piece to get rid of my 2, this -1, and this 8. Okay, now it's in slope-intercept form, y equals mx plus b, so I can pick out my slope and compare these two numbers. How do positive 1/2 and negative 1/2 compare? Are they the exact same number? No. Are they opposite signs and flipped fractions? So yes, they're opposite signs. This one's positive and this one's negative, but the fractions aren't flipped. So no, this one has to be signs and flipped fractions. Two criteria to meet if it's perpendicular. So since only one of those criteria is true, the opposite signs, it's not perpendicular. That means that these two lines are just neither. If you plot them, they're going to cross, but not at a nice, pretty straight corner, 90-degree angle. Let's do one more example. All right, let's compare 2x plus 4y equals 9 and y equals 2x minus 9. This second one is already written in slope-intercept form, so we can pick out our slope quickly. The first one we need to rewrite, so I am going to subtract my 2x over to the other side and then divide by 4. Simplify your fraction. And now this is my slope. Okay, how do negative 1/2 and 2 compare? Well, 2's not written as a fraction, so that might throw you off for a minute, but any number can be written as a fraction. All you have to do is put it over 1. Every number is implied to be over 1. We just don't write it because that seems weird. But if you need to write it that way to help you compare your fractions, it might help you. Are these two parallel? Are they the exact same number? No. Are these two perpendicular? Do they have opposite signs? Yes, one's positive and one's negative. And are they flipped fractions? Yes. So since it's both opposite signs and flipped fractions, they are perpendicular. Example 3, given this line, write the equation of the parallel line that goes through the point 1, -5. All right, well first we know this is a parallel line. This is the slope of our original line. A parallel line is going to have the exact same slope. And now we have this coordinate point here. We need to figure out what the b value is. We normally write things in slope-intercept form, so we know what m is, but what's b? Remember, there are two ways for you to do this. You can either write this as your x and your y, sub them in for the x and y here, and solve for b. Now that we know what b is, write the equation y equals mx plus b. Or if you don't like that format, remember you can use point slope form. And this would be your x1 and y1. You get the same answer, it's just preference. Do you prefer to solve for b and then rewrite, or put it in point slope form and solve for y? Let's do part B now. It's going to be a similar process, but now instead of our line being parallel, we're going to be perpendicular. That means we need to take this original slope and flip it and change the sign. Since that was a -1, now our slope is going to be positive. So we're going to do the exact same thing we did before. You can either do it this way where you solve for b and rewrite, or point slope and solve for y. But now I'm going to use this as my m value, and I happen to have the same coordinate point. I have one example for you to try. Write the equation of the line that's perpendicular to y equals 3x plus 1 and goes through the coordinate point 6, 2. So for this one, we're perpendicular. That means I need to take this slope and flip the fraction and change the sign. It's not written as a fraction, but every number can be rewritten as a fraction if you write it over 1. So my slope is going to be flip the fraction and change the sign. It's positive to negative. And now you can use either of the methods before. This is my coordinate point. And you should get y equals -1/3 x plus 4.